Okay, let's go over ions for a little bit. So there's as I mentioned many times before, an ion is really an atom that has a charge. It's either because it's gained or lost electrons. Now, I had my students actually create flashcards for themselves and write it out, and that helped them a lot. They 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 moaned and groaned about it, and why do we have to do this? But then they did better, and the class behaved better, and it just worked out better in general for everyone. But because people don't want to bother with that, I created a set of flashcards. Let me show you. So I created these ion flashcards, and you can get them from my company, scienceglen.com, or you can get it from Amazon. They're there, and so it's a good thing, all right? So I go over the name and symbol, but let's go over a few of them so you can see it, okay? So here's potassium ion, and so you have the name of it, and then on the other side you have the symbol for it, okay? And you have the charge. In this case, potassium, like all the metals, and particularly the alkali metals, those are the ones in column 1, they lose 1 electron. So you can see here, it lost 1 electron, and so it has a charge of K+. Let me make that a little bigger so you can see it. So, okay? Now, in terms of the electron configuration, it's the 4s1 electron that comes off. So then it becomes like argon. So when an alkali metal loses an electron, it becomes like the noble gas in the line above it, which in this case is argon. Okay? So now, on the other hand, if you have, let me pick another one here. Here's beryllium. Okay, so beryllium is an alkaline earth metal. It's in column 2, so it loses 2 electrons. It loses both of the s electrons there and becomes like helium. Okay? So those are all straightforward. Now, when you get to things like the polyatomic ions, in this case, then you have a carbon atom that is covalently bonded in a triple bond and has an overall charge of -1. It's covalently bonded, so the C and N are covalently bonded there, okay, with 3 bonds. It makes it a very stiff structure, okay? And it's in shape, it's linear in shape, and the angle is 180 degrees if you remember your geometry, okay? But it acts like an ion because it has a negative charge. And this shows the Lewis structure of it with the dots and things, okay? And let's look at another one. So here's chromate. Chromate ion. I was doing a video with this yesterday, okay? So chromate ion is a chromium and 4 oxygens all grouped together, again with a covalent bond. It can have different shapes. If you look at the Lewis structure, okay, where the single bond is there, or where the double bond's there, that can modify, that can change. That's what's called resonance. And it takes a tetrahedral shape with those kind of angles, okay? And you see those dashed lines there? That means that it's flexible to some extent. Not in the way of bending, but where the actual double bond is, it moves around, okay? And it's tetrahedral shape, and there's a 190-degree angle. But this thing overall, even though it's got those covalent bonds between all those atoms, it has an overall charge of 2-. Okay, and by the way, there's 6 different resonance structures. There's only 2 of them that I'm showing there, but there's a whole bunch of it in terms of where the double bonds are, where the single bonds are. So that's what I show. That's chromium. Okay? So you can see some of the things here. Let me just grab another one here by chance. So I also created these ionic bond disk models. And so for potassium, you can see, if I get that in focus here, doesn't want to be in focus. Be in focus, come on. All right. So it's got a +1 charge because it lost 1 electron. Okay? And if I take that cyanide that I was telling you about, if I can get the thing apart, here we go. Here's a cyanide. It's got a -1 charge, so I can just stick it together. So now I have potassium cyanide. Potassium cyanide, okay? And so it has all, the plus has been covered with a minus, and 1 minus 1 is 0. You have to have a 0 charge overall for it to be stable, okay? Not every ion is stable, but many are. And then there's all kinds of solubility rules and things on. But these are ionic compounds, and whether that is a potassium or whether it's some other thing. And again, here, let's see. Gold 3. Here's another one. This is a transitional metal. That's Roman numeral 3. It loses 3 electrons. Okay? But where? Well, it loses 3 electrons. It comes Au3+. It used to be called aurum. That's why it's Au. And it's got this structure. And if you look at this, it's losing the 6s1 electron, and it's losing 2 of the d electrons. Okay? Now that's gold 3, but there's also a gold 1. The transitional metals will lose an s electron, and sometimes they'll lose d electrons. Okay? And so you get things like gold 1 and gold 3 and copper 1 and copper 2 and so forth. Anyway, by using this ion flashcards, pardon me, from Science Glen, that's me, okay? And people liked it. It does well. It's got 41 reviews. That's 4.9 stars. So people like it. It's really good. There's a few minor things I'm going to change in the next version of it, but it's really effective, and it will make your life a lot easier. And once you go through those cards 4, 5, 50, 500 times, it'll be so automatic for you, you won't even think about it. And if somebody says bromate, you go, oh, that's easy. It's BrO3 minus. Big deal. Okay? And you won't stress about it. And then how you name it. Now, by the way, the naming is to have the cation name the positive ion first, and then the anion name. Positive, negative always. All right? Best of luck.